Welcome to a tutorial of ProfLearn YouTube channel. In this particular video, we're going to have a discussion on astrophysics of IGCSE Edexcel Physics. So we're going to have a candid discussion on how to answer questions to do with cosmology. And what's something that you need to understand is that cosmology is the study of the universe. And, is the study of the origin of the universe. So which means that we are going to explain the theory that explains origin of the universe, which is Big Bang theory, and we're going to also look at different evidence that support Big Bang theory. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. One of the questions that was asked in one of the year is that student was supposed to describe how two permanent magnets can produce uniform magnetic fields. So for you to produce or generate uniform magnetic fields, something that you need to do is to bring two magnets close together, and you ensure that the poles which are next to each other are having opposite poles. And in that way, you're going to have uniform magnetic fields. You can see the fields are straight and equally spaced. That is what we mean by uniform magnetic fields. So that is how you are supposed to respond. And the diagram shows a proton moving in a circular path at a constant speed. The uniform magnetic field, in a uniform magnetic field, this motion is similar to the movement of planets in the solar system. Now, draw an arrow to show the direction of the force on the proton. The force is a centripetal force, which is always directed towards the center of that particular object. Now, for you to measure the diameter of this diagram accurately, what you need to do is to measure the distance from end to end, and then you work out the average. You take more readings, and then you find the average for that, and you find your answer approximately 6.5 centimeters. Now, in order to calculate the orbital speed, remember, orbital speed is given by the formula V is equals to 2 pi r over t, whereby r is the radius of the orbit, t is the period, all the time taken for the object to move around that particular orbit. So in this case, we had worked out the question. I think I have to ensure that this is corrected here so that we can be able to go ahead, because the time or the measurement that we had taken here was diameter. So if this is the diameter, we have to find the radius by dividing this by 2, so that will be 3.25. And then I have to divide these centimeters by 100 so that I convert this to meters, such that my speed is going to be meters per second. So you can see this is radius, so meaning that this diameter, we have to divide it by 2 to use it this given point. And the period was given as 8.7 times 10 to the power minus 6 as such. In question number 2, we are talking about Hertzsprung-Russell diagram. This is a HR diagram, which are usually diagram which can be able to identify different region which a star is in its life cycle. So the middle part here, we are going to have this region here. We are going to have the main sequence. The white dwarf is somewhere below here, and then we have the red giant, and usually the red supergiants are much above here. Red supergiant. So candidates were given different descriptions so that they could be able to identify. Star W is a white dwarf. So where should it be? It should be somewhere here. Star X is a red giant. So it's above, star X is above the main sequence. We have said the star is in the main sequence. So the red giant will be somewhere there above. And that is why we have this particular region here. Then we have Y is a main sequence that is much larger than the sun. So we can be able to say, right, I can say Y is somewhere above to the left If it's larger, it's more bright, but also it's let me just remove this. So that is, let me remove this. Yeah, so that Y will be here. And then we have Z has the same surface temperature as the sun, but will be dimmer than the sun. So if it's dimmer, it will be surface temperature to be the same region, vertical line, but below, so that it's a bit dim, a bit dimmer. And then we have question number part E. The moon is the brightest object in the sky at night. Suggests why the moon cannot be shown on the Hertzsprung diagram. Why can't the moon be shown on the HL diagram? This is because the moon is not a star. The moon does not provide or produce its own light. And also we can be able to say the moon's surface temperature is too low, so it cannot be able to fit in the scale of the HL diagram. So basically those are the reasons we are going to state as far as this particular concept is concerned. So moving further now, we can be able to define. There are different terms that you need to understand their definition because astronomers can be able to describe brightness of a star based on or in terms of apparent brightness and also absolute brightness. So if you are told to describe brightness of a star, it can either be absolute magnitude or absolute brightness or apparent brightness. Apparent brightness is how bright a star appears from Earth. Because at night when you are observing different stars, you observe that some stars are bright and others are dim. So apparent brightness is how stars appear, how bright stars appear from Earth. But absolute brightness is a measure of how bright stars will appear if they were placed at a standard distance from Earth. And usually that standard distance is 32 light years, or is 10 parsec. So this is how bright. So you can be able to comparatively compare how bright stars are effectively when you're using absolute magnitude. Yeah, right. So the evolution of stars can be shown on Hertzsprung diagram, HL diagram. Complete the HL diagram by labeling x-axis, completing the absolute magnitude scale. Then we can be able to show the main sequence, red giant, and the white dwarf. That is exactly what we have done the other questions above here. You can see down here we have color, we have magnitude, absolute magnitude, then we have white dwarf, main sequence, red giant, and the super giants. So these are questions which are very, very common when it comes to your exams. So let's see. On this, as a candidate, you are supposed to ensure that you label these positive 10, positive 15, and then positive 5, 0, negative 5. And then the white dwarf will be well seated there. We have the main sequence well illustrated here. And then you ensure that also you are going to have the red giant just above the main sequence. So in the event you are given question, in the event yeah, so let me just give those guys who usually watch from, yeah, this is for those guys who usually watch from TikTok, because some guys don't check ProfLearn YouTube channel. Guys, if you are watching from TikTok, make sure you go to ProfLearn YouTube channel so that you can be able to see the fullness of this particular tutorial. So let me show them so that they can be able to see exactly what we were talking about in this particular lesson. You need to understand the Hertzsprung diagram, the Hertzsprung diagram. You can see up here we have the main sequence. This section we have the main sequence, and here we have the red giant, and this other section here we have the white dwarf. X-axis is labeled as color, and the y-axis here we have the absolute. We have the absolute magnitude. Absolute magnitude. And we have already said that absolute magnitude is the measure of how bright stars will appear if they were placed at a standard distance from the Earth. All right, so let's look and see. The rest of the question that's gonna be asked. What is a star formed from? A star is formed from gas and dust particles, which is called nebulae. It's called what? Nebulae. Then which of these indicate the universe, that the universe is expanding? What indicates that the universe is expanding is the galaxies are moving further away from each other. Which of these provide evidence for Big Bang theory? What provides the evidence for Big Bang theory is the presence of microwave background radiation, which we call usually the CMBR. So CMBR serves as the evidence for Big Bang theory, meaning that they were produced during Big Bang. All right. Which of these provide evidence for Big Bang theory? We have said cosmic microwave background radiation's presence. So that which of these does redshift provide evidence for? Redshift shows that the universe is expanding, that the galaxies are moving away. So that is basically what that indicates. I've said what does redshift provide evidence for? That the galaxies are moving away and indicates that the universe is basically expanding. Then we are told that the spectra of stars and the galaxies shows lines at specific wavelength correspond to spectra of hydrogen and helium and carbon. Give reasons why lines corresponding to these elements. Which elements are we talking about? We're talking about hydrogen, we're talking about helium, and we are talking about carbon. So which means that give a reason why lines corresponding to these elements are found in the spectra of galaxies. The reason as to why spectral lines or corresponding to these elements are found is because inside a star there is fusion of hydrogen. There is hydrogen. There is a larger content that is inside a star is basically hydrogen, and for that reason hydrogen is fused to form helium and helium is fused to form carbon. Now for that case you are going to have traces of spectral lines of hydrogen, helium, and carbon because they form a star. Yes? Right? So that's why I say that stars are mostly made of hydrogen. So hydrogen shows up clearly in the spectrum. And also helium and carbon, because fusion of hydrogen and hydrogen result to the formation of helium, and the fusion of helium result to the formation of heavy metals such as carbon. So in that case, helium and carbon are produced inside a star. So also, since they are also present, then it means that light from that is also produced. Then moving further, we are going to calculate the change in wavelength. And for you to calculate the change in wavelength, you can see you need to take a reading from this particular point here. And also you take a reading. This one is 760 and this is 655. And then if you find the difference from that, you can be able to determine the change in wavelength, which is going to be 105. Now, to calculate the value of recessional velocity of quasar using a value, we are going to use change in wavelength of the original or the standard wavelength, and is equals to V of C. Now, right? So if you substitute and you rearrange this formula, we're going to have speed of light times change in wavelength is going to be equals to the original wavelength, and the original wavelength is the initial wavelength of light in the lab, and that is going to be 655, because you see standard hydrogen spectrum is this, and that is going to be the lambda naught that we're going to use in this particular case. And light that is observed from quasar is going to have a longer wavelength. That's why it's basically displaying what we call a redshift. Now, in that case, if you try to substitute into this formula, we're going to get our speed to be 4.8 times 10 raised to the power 7 meters per second. Astronomer observed light from nearby galaxy. She notices that spectra of hydrogen from light inside left side of the galaxy are different, and also that of the center is basically the standard one. So this one, you can see the spectral lines. This is the central one. So comparatively with this central spectral line, it means this one has shifted to the red section, because if you look at this line here, it has shifted to the red section, to the longer wavelength. But for this one, it has shifted to the shorter wavelength, which means it's a blue shift. So for the left side is a blue shift, and then the right side is a red shift. So which means that we can be able to make observation about the motion of the galaxy in this case. So since all the galaxies displaying both redshift and blue shift, it could be that one section, the star is in such a way that the star is spinning. So if the star is spinning, it means that one section will be approaching the observer and the other section will be moving away from the observer. This section will be approaching, this one will be moving away. So this one that is approaching will show a blue shift, and this one that is moving away from the observer will show a red shift. So in that way, you can be able to tell that the left hand side shows a blue shift, and the right hand side shows a blue shift. So the the right hand side shows a red shift. This shows that the galaxy is basically spinning. That is why one section is moving towards, as it's spinning, is moving towards the observer, so it will be a blue shift. The other section moving away from the observer, so it will be a red shift. And usually this is what we call sectional stars, types of stars, which are called binary stars. They exist in an axis, one as they are moving, the galaxy is moving away from the Earth, but still those stars are basically spinning round. Yeah. So we have areas to tick to support Big Bang Theory. Remember, Big Bang Theory is a theory that tries to explain the origin of the universe. And remember, Big Bang Theory claims that the universe originated from a single hot and dense point, which expanded to whatever we have now. So in that way, in the process, there was cosmic microwave background radiation that were created. That's why if you go anywhere in the universe on Earth, you can be able to measure CMBR, cosmic microwave background radiation. They are present everywhere because they were created during Big Bang. And also, since the universe is expanding, then it means that it's in line with Big Bang Theory. Because if you observe light from distant galaxies, you realize that these galaxies, they display a redshift. So if there is a redshift from distant galaxies, it means that the universe is still expanding until now. So this is most galaxies shows a redshift that is detected from Earth, so indicating the universe is expanding. and also microwave background radiation is detected in all directions anywhere on Earth, and that means it could have been produced during Big Bang. The sun becomes a red giant star when it leaves the main sequence. Then the surface temperature will decrease and the brightness will increase in that case. State what's meant by absolute magnitude. I've already mentioned that absolute magnitude is the measure of how bright stars will appear if they were placed at a standard distance from Earth. And that is basically what we call absolute magnitude. But also, if you're going to be asked about apparent brightness of a star, you're going to say this is a measure of how bright stars appear from Earth, just like that. Explain how cosmic microwave background radiation supports Big Bang theory. And we have said that they were produced during Big Bang. CMBR appear to be the same in all directions, which implies that all parts of the universe were in contact long time ago. And also we can say the wavelength of CMBR has increased as the universe expanded, showing that the universe was significantly hotter a long time ago, and this basically matches the prediction of Big Bang theory. And in the event you are given questions to do calculations from redshift, something that you need to understand that hydrogen has this wavelength, but when it's observed is having this. So meaning that according to our formula, this is our lambda and this is our lambda naught. Okay, yeah, so this is the standard wavelength, but observed wavelength is usually longer. That's why you can see is lambda minus lambda naught over lambda naught is equals to speed of the galaxy divided by the speed of light. So if you try to substitute and you work it out, you're going to get your answer being around 3.9 times 10 to the power 7 meters per second. Question number 7 was asking candidates to whether they understand the relationship between speed, frequency, and the wavelength. And that is exactly what these candidates wrote. Show that the mean CMBR is 2. So meaning that we're using wavelength and speed to calculate that. Remember, CMBR also travel the speed of light. So that's why you can see I'm using that. So lambda is V of frequency. Frequency was well provided. And if you work out your distance in a wavelength in meters, you're gonna get this. And therefore, after you do that, you can be able to convert this to millimeters, which is you multiply meters by 1,000 in order to get your answer in that point. Use the information to show that it supports Big Bang theory, CMBR. The wavelength of CMBR has increased since then, and over time, the universe has expanded. So basically, this serves as the evidence for Big Bang theory. Explain how the cosmological redshift, explain how the cosmological redshift shows galaxies, redshift of galaxies also support Big Bang theory. We have said there are 2 evidence that support Big Bang theory. Number 1 is the presence of CMBR, presence of microwave background radiation in the universe on Earth, then also on the universe rather, and also the redshift that is observed from distant galaxies. So that also supports. All galaxies shows a redshift, so meaning they are moving away. And this moving away, all parts of the earth of the universe moving away, is because the universe is expanding, which is actually a claim of Big Bang. So that is exactly what you are supposed to write in this particular section for you to earn those 4 marks. Yeah. And something also you need to understand is that distant galaxies, those galaxies which are very far, they have a larger redshift, so meaning they're moving away faster. Pieces of evidence, this one we are not going to repeat, that's a walk in the park. And application, already we have worked on that. So evolution of the universe since then until now. What has happened since then until now? So what we need to understand, the universe began as a hot dense point, and the universe has expanded and it has cooled down. So those are the evolution, all different changes that has taken place since the universe was created until now. As it's expanded, cooled down, right, like that. Describe evidence that support Big Bang theory. We have said the presence of CMBR, and all galaxies shows a redshift. All galaxies display a redshift. So basically that is how you are going to write your answers. For you to earn your marks, you can put it down so that you can be able to proceed to the next question. State what's meant by a galaxy. A galaxy is a collection of billions of stars. Which of these billion of galaxies is actually the universe? Well, when you have a laboratory sample showing this, galaxy A is having 656.21, so meaning it's less than this, which means this is a blue shift, meaning this star A is moving towards the Earth, and star B is moving away from the Earth because it has a longer wavelength. So which indicates that this could be binary stars which are orbiting. One star is when they are orbiting, one star is moving towards the Earth, so it shall show a blue shift. The other one that is moving away should have a red shift. That's why you can see the wavelengths a bit longer, and the value is larger, so meaning it's moving away faster, because the faster it starts moving, the larger the wavelength is. So basically that's what you are going to do in that particular question. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime we're going to have more tutorials on that, you'll be notified. You can be able to access the PDF of this paper that we have here in our Patreon page, so that you can be able to now answer the rest of the question for practice for your exam. And also I'll be able to include the marking scheme for the same. See you in the next one.